Alright, welcome to 4-1, Factors and Monomials. Our objectives today are to determine whether one number is a factor of another and determine whether an expression is a monomial. Before we begin, we're going to review three key terms. First one is factors. The definition is two or more numbers that are multiplied to form a product. Alright, and in translating, we've been using product as one of our words. But now we're going to use product as the end result. So basically, 2 times 2 are factors of 4. So it is these two numbers that are considered the factor. Let's clarify divisible. And it's not necessarily a definition, but an example. 4 and 9 are factors of 36 because they each divide 36 with a remainder of 0. We can then say that 36 is divisible by 4 and 9. So that's something that we've normally done in the past, just haven't really given it a name or really have a solid definition or example. So divisible. Our third definition is monomial, a number, a variable, or a product of numbers and variables. As you can see here in the first one, this is just a number, our constant. We can call that a monomial. Then we have a variable, which is a letter that represents any number. So that's a monomial. And then finally, we have this. This is a product, and this product is -2 times r times s. Since it's multiplication, we consider this a monomial. What are not monomials is just as important. And it's very easy to find out if it's not a monomial because it's going to be separated by adding or subtraction. Like in the first one here, we have 2 plus x. They're being added. So those are two monomials, not one. Look at the next one, 5c. I know we're multiplying, but once again, it's separated by a subtraction sign. So it is not a monomial. And then the last one, even though we have parentheses and we could get a monomial, we know this is the distributive property. And the distributive property usually results in two or more terms. In this case, you can see the final result here is that we have two terms instead of one, or a monomial. What we have here is divisibility rules. It's something that every student should memorize, or at least get used to. It'll help you speed up your situations when you're trying to find factors, especially when we start factoring later on with trinomials, etc. These 5 that you see here on this page are pretty much the easiest to remember. First off, we know that a number is divisible by 2 if the ones digit is divisible by 2. So look at 54, and with 54, you can see that the ones digit is 4, and 4 divided by 2 is possible. We now know that our next number, 3, a number is divisible by 3 if the sums of the digits are divisible by 3. What we do is we add all the digits together. So in 72, 7 plus 2 is equal to 9, and we know that 9 is divisible by 3. Our next one, a number is divisible by 5 if the ones digit is a 5 or a 0. So once again, we look at our number, we go to the ones place, and we notice that there's a 5 there. Or if there is a 0, we know that that number would have been divisible by 5. Now, in order to use 6, or if a number is divisible by 6, you have to know the rules for 2 and 3. And we do know that 48 is divisible by 2 because 8 is divisible by 2. And 4 plus 8 is 12, and 12 is divisible by 3. Therefore, it's divisible by 6. And the last one, just like 5, 10 has one where you just observe. We go to the ones digit, and if there's a 0 in it, it's divisible by 10. There are other ones. There are other charts to memorize. There's one for 4, there's one for 7, there's one for 8, there's one for 11. But right now we're going to start off with these 5, and you should get used to them and use them as much as possible. All right, Determine whether 138 is divisible by 2, 3, 5, 6, or 10. All right, here's a chance to put in what we just learned on the last slide into action. All right, 138. 138, the ones digit is 2, or is it divisible by 2? And the answer is yes, because 8 divided by 2 is true. Next up, 3. 3 says that we should add 1 plus 8 plus 3. Sorry, that's out of order, but we can still work with it. That's 12. Is 12 divisible by 3? The answer is yes. Now, 138. Does the one digit have a 0 or a 5? The answer is no, so it's not divisible by that. Now, here where it comes into 6, all we have to know is it divisible by 2 and 3? We did that work already, and they're both yes, so the answer here is yes. And the last one, 138. Is the ones digit a 0? And the answer is no. There you go. So it is divisible by 2, 3, and 6, and not divisible by 5 or 10. That'll help us later on when we were doing factoring. Here is a word problem that involves using those rules that we just learned about. And here it is. A bride must choose whether to seat 5, 6, or 10 people per table at a reception. If there are 192 guests and she wants all the tables to be full, which should she choose? So what she wants to know is that can she put 5 at each table and there will be no seats left over, or 6 at each table and there will be no seats left over, or 10 at each table and there will be no seats left open or over. First off, we need to see if 5 can go into 192. Well, in 192, we look at the ones digit. There is no 0 or 5, so the answer is no. We're not going to have tables set up for 5. Let's look at 6. Well, the 6 says the rule for 6 is that is it divisible by 2? And the answer for that is yes, because 2 is in the ones digit, and that's divisible by 2. Next, we need to see if it's divisible by 3. So we'll just go 1 plus 9 plus 2, and that gives us 12. And 12 is divisible by 3. That's a yes. So, there we go. 6 is one of the options we have. We just need to check 10 just to make sure to eliminate it. 192, ones digit. No, there's no 0 there. So we're going to use 6 people per table for her setup for her wedding. And there will be no seats left open. A good use of all the tables. All right, list all the factors of 72. Use the divisibility rules to determine whether 72 is divisible by 2, 3, and 5, and so on. And then when we run out of the rules, we're just going to use division to find out the other factors of 72. We always start off with 1, and 1 times 72 is 72. So we know that 1 times 72. Those are our first set of factors. 1 times 72 is 72. Then we look at 2, and we know over here to the side that there is a 2 in the ones digit, so somehow we know that 2 times something is equal to 72, and we can solve this by using steps in solving the equation. Divide both sides by 2. That leaves us with 36. So 36 is one of them. Now 7 plus 2 is 9, so therefore that 72 can be divided by 3. So I need a number. 3 times something equals 72. Well, how am I going to figure that out? I'm going to divide both sides. I'm going to divide 72 by 3, and I get 24. Now, I don't have a rule for 4. So I'm just going to go ahead and use division. And 4 go into 72. And I use a calculator, and the answer is yes, and that's 18. Does the ones digit in 72 end in a 0 and a 5? No, it doesn't. So 5 is not a factor. We know that 2 and 3 can go into 72. That means 6 can go into 72. So I take out my calculator and I say to myself, how many times can 6 going to 72, and the answer is 12. Now, I'm just going to go ahead and plug in 7. I don't have a rule for 7. And I find out that there is no number. 7 can't go into 72, so the answer here is no. Then I look at 8. I don't have a rule for 8, so I just go ahead and divide 72 by 8, and I find out the answer is 9. And then I go ahead and, well, believe it or not, this is 8. Here's a good tip. When you see numbers or the factors repeating, then you can stop. That means you found all the factors. The factors for 72 are 1 and 72, 2 and 36, 3 and 24, 4 and 18, 6 and 12, and 8 and 9. And like I said, you don't need to do 9 because it repeats. So there you go, ladies and gentlemen. That is using the rules and divisibility to find the factors of numbers. Alright, determine whether each expression is a monomial. Well, what we need to do here in the first one is get rid of the parentheses, and we're going to use what we have known in the past that's called the distributive property. So we get 2x minus 6. Notice that we can't combine these two together because they're unlike terms. Now, is this a monomial? The answer is no, and the reason is because these two terms are separated by the subtraction sign, so the answer is no. Let's go to the next one. What we have here is we have negative 48 times x times y times z. And that's a monomial because of multiplication. It's not separated by adding, subtracting. Multiplying is okay. So yes, this is a monomial.